The function f is defined by f of x equals to ax square positive bx positive c, where a, b, and c are constants. The graph of y equals to f of x in the xy plane passes through the point 7, 0 and negative 3, 0. If a is an integer greater than 1, which of the following could be the value of a positive b? Okay, now let me consider the given function f of x, that is f of x equals to ax square positive bx positive c. Actually, it is a quadratic function. So whenever we have a quadratic function in this form, its graph will be a vertical parabola in the xy plane. And the parabola may open up or may open down. It depends on the value of the leading coefficient a. If a is greater than 0, the parabola will open up. If a is less than 0, the parabola will open down. And the question says a is an integer greater than 1. Since a is an integer greater than 1, so here a is greater than 0. So the parabola we get for this quadratic function, the xy plane, will open up. And also, when I look at the points through which the graph of the given function is passing, there is 7, 0 and negative 3, 0. In both the points, y coordinate is 0. Since the y coordinate is 0, these 2 points represent the x-intercepts of the graph of y squared f of x. I mean the parabola given by the function f of x. Okay, let me draw a rough sketch of the given quadratic function. Let me do it. So the question clearly says the parabola has 2 x-intercepts 7, 0 and negative 3, 0. Let me mark negative 3 over here and 7 over here. So, and also the parabola opens up because the value of a is greater than 0. Because the question says a is an integer greater than 1. Since it is greater than 1, it is also greater than 0. The parabola has to open up and also it passes through the points 7, 0 and negative 3, 0. 7, 0 over here and negative 3, 0 is over here. Okay, now for this quadratic function f of x equals to ax square positive bx positive c, if I want to get the exponent of the vertex, so this is the vertex of the parabola. If I want to get the exponent of the vertex, so there is a formula to get the exponent of the vertex, that is, I have to take negative sign and I have to take the coefficient of x, which is b, over 2 times the coefficient of x square. So this is the formula we have to get the exponent of the vertex. And also, using the 2 x-intercepts of the parabola, we'll be able to get the exponent of the vertex. How? So it's very simple. We just have to find the average of the exponents of the 2 x-intercepts. So that is, if I find the average of the 2 x-intercepts, I'll be getting negative 3, positive 7 over 2. So the average of the exponents of the 2 x-intercepts represents the exponent of the vertex. So this is a formula we have to get the exponent of the vertex when the quadratic function is given in this form. And this is the exponent of the vertex we are getting from the given x-intercepts. So both of them represent the same stuff, that is exponent of the vertex. So we can equate them. So then we get negative b over 2a equals to negative 3 positive 7 over 2. Then I'm getting negative b over 2a equals to, when I simplify this one, negative 3 positive 7, I'm getting 4 over 2. Then I'm getting negative b over 2a equals to, so 4 over 2 is just 2. Okay, now to get the 2a in denominator, I have to multiply both sides by 2a. Let me do it. So when I multiply both sides by 2a, this 2a will cancel out. I am getting negative b is equal to 4a. Now, if I multiply both sides of this equation by negative 1, I am getting b equals to negative 4a. If I multiply this negative b by negative 1, it becomes b. If I multiply this 4a by negative 1, it becomes negative 4a. Actually, our aim is to find the value of a positive b. Okay, let me write that stuff. A positive b equals to. Just now we got the value of b in terms of a, that is b equals to negative 4a. So we can plug in negative 4a for b over here. Then I'm getting a positive of negative 4a. Now a positive b equals to a positive times negative equals to negative 4a. Then a positive b equals to, when I combine a, negative 4a, I'm getting negative 3a. Okay, now let's consider the information we have in the question, that is a is an integer greater than 1. That is a is greater than 1. Okay, now I multiply both sides of this inequality by negative 3. So when I multiply this a by negative 3, I'm getting negative 3a. When I multiply this 1 by negative 3, I'm getting negative 3. Whenever I multiply or divide both sides of an inequality by the same negative number, I have to flip the inequality sign. It's already greater than, since I multiply both sides of this inequality by the same negative number, that is negative 3, I have to change this greater than sign to less than. So now I'm getting negative 3a less than negative 3. Since a positive and negative 3a, both of them are equal, we can plug in this a positive b for negative 3a over here. Then I'm getting a positive b less than negative 3. So therefore, the value of a positive b is less than negative 3. Any value less than negative 3 can be considered for a positive b. Okay, in the given answer choices, we have the value of a positive b. So we just have to pick the one where we get the value which is less than -3. So clearly -6, I mean the value we have in option A is less than -3. So among the given answer choices, -6 could be the value of a positive b. So the correct answer choice for this question is option A.